Well, hi, good morning, and thanks so much for joining me here in my shop, keeping me some company so I'm not alone with this little beast here. So today, what I hope to do, I hope to finish this radio right off today. That's my goal. So we have a number of capacitors in here that need to be changed out. 1, 2, 3, 4, 5, and 6 of them. Some of these are going to be in the RF part, the front end part of the radio, and some of them are going to be in the audio section of the radio, and I'm just wondering whether I should just, oh my god, shotgun these guys? No, never shotgun capacitors. They all look really easy to do, except for this one's a little bit hidden in there. They're all, otherwise they're right up on the surface, kind of. Well, maybe what I'll try to do, I'll try to figure out which ones are, for instance, the audio ones. Maybe there's 2, 3 in here. Change those, test the radio, change the rest, test the radio, and then we'll go on with the alignment, which is really what I want to do today. That's all part of finishing it off. Just looking it over here. I got to change the cord. It's a bit of a hassle considering the way it is here. I don't really like doing it. Like this wire is bent way out here, but it's so stiff I wouldn't dare try to move it. That's coming right out of the transformer here. So you kind of have to work with the wires where they are, and then it's trouble. But I think this cord's got to be, should be changed. Okay, that's it. That's the plan. That's the plan. Away I go. Okay, so I've changed 3 that I believe are in the RF part of the radio. I've left these 3 in over yonder because I think they're in the RF, the audio part, RF part. Did I say that right? So we're going to test these capacitors here with my new to me capacitor checker, which from my experience so far with it is a very sensitive unit compared to my old capacitor checker. So this one is a 0.1. What it was doing in the radio I haven't bothered to check. 0.1 typically, that would be probably on screen circuits to quiet a screen circuit or something like that, but I don't really know. Okay, so we're going to check the amount of leakage. So I'm going to flip this to leakage. The eye should, if there's no leak, the eye is wide open the way you see it right now. There we go. So on this capacitor checker, with putting only 3 volts onto the capacitor, this checker is suggesting it's a leaker. It's a leaker already. Wow. Let's just go through them. I'll just leave it on. 3 volts here. It's another one that's a leaker, according to this unit. Lots of wax on there. Leaking too. So because I need to sort of train myself on this unit, which I think is going to turn up every capacitor as a leaky capacitor, unless you show it a brand new one. Let's just show it a brand new one here, just to reassure myself. So you saw it close momentarily while it charged the capacitor, then it's open. That's 400 volts on that capacitor, and the eye is open. So just put this into discharge mode for a moment and discharge that capacitor. 400 volts. A little capacitor like this with 400 volts on it, I don't know what you would feel if you decided to manually discharge it with your fingers. I don't know. So what we're going to do is we're going to test these 3 again for calibration, for my own personal calibration sake with this guy. Now this guy I've been using for a few years. I've gotten really used to what it shows. And some older capacitors that look to be in good shape test fairly okay here. They never test great. They test fairly okay. Okay, same capacitor, same deal, only this is the control now. Flip it to leakage, see what the eye does. Oh my gosh, well it's not disagreeing at all with the other machine, is it? Now that's 50 volts. This one starts at 50 volts, the other machine starts at 3 volts. 3 volts is hardly anything. Well, okay, so no difference here between the two testers. So from my experience, just relying on this tester, these capacitors are very bad. That's how these are testing. Very bad. So the fact that they leak on 3 volts on the other tester, yeah, I think that's in total agreement with very badness. So we're going to try the radio here and see how it works. Surely to goodness, capacitors this poor must be having a degradatory effect. Another new word. Another new word from me. Okay, power off to the outlet. In we go. So because I've made changes in the radio, and that sometimes comes along with mistakes, we'll keep our eye on the dim bulb here as I energize this guy. Hey, this light wasn't working before. That's interesting. I'm gonna just take him out because we don't want that scaring away. Here we come. Terrible noise with volume right down. So that noise is entering somewhere into the audio circuits past the volume control. Oh, that's not very good. That's a whole load of nothing. Isn't that, doesn't that make you wonder what the heck did I do to the radio? Let's just juice up the antenna here a little bit. Just a bit. Oh heavens, what just happened there? It's a total shutdown. What happened? Can anybody tell me? we're going downhill rapidly here. It just shut right down. Oh man, okay, tube loose in the socket. I did pull these tubes out and cleaned them up. You notice everything is a little bit cleaner today than it was yesterday. But I did not test them. This one has a little bit of trouble seating. It's in there. She's gone totally dead. I killed it. Now, what occurred? Who knows? What am I supposed to do now? Turn it off. That would be a good start. Yes, we're going backwards. The remote chance I changed those capacitors and that's raised the B plus high enough to pop some other part. For the first time getting a full. What I'm going to do is I'm going to carry on. I'm going to get rid of these capacitors even though we got trouble here. Then I'll deal with whatever the heck just happened. 3 more to go. Okay. Not quite what I was hoping for. Okay. I've got all those old capacitors out of here now. soldering on them. Good, everything's soldered in good. Let's see what we get. What do we get this time out here? Hey, let's test some capacitors first. So, any surprise coming here? I'm going to test them on this tester because I've left it on. And we know how it compared the last few. Let's check these. Would you expect them to be any different? No. Okay, here we go. 50 volts. It almost opened. So it was not quite as horrible as the rest. A lesser degree of horrible. There we go. It's another one doing nothing. These are surprisingly bad capacitors because they don't look that roughed up. But they are. So I know if this has been sitting in some very humid environment, outdoors in a garage or something, you know, these things are they're going to absorb moisture over time, clearly, even with the wonderful beeswax on it. Okay, so that was worth doing. Obviously, all those capacitors were sad. Now, the question is the radio happy now? Let's find out. Volume is. Okay, I'm going to apply power. Watching the lights. In case I booped up big time. Not at all. Okay, tube's lighting. Let's give it the full. No, that's not. Let's leave it on the dim bulb because we're really giving it 119 volts. And that's full voltage. Well, that sounds like a radio now. Oh, what are you looking at? Look down here. So the buzzy sound is the speaker here, with the rattly sound is from the speaker. I think it sounds like a radio now. Okay, that's full volume, but I'm not helping the antenna. Let me put on the help. Here comes some help. Down with the volume. Well, it's not picking up anybody yet. So we should see right here at 640. Not a soul. So it's picking up some interference and noises, so it's doing something. And then we have a 680, which would be right in here. I hear a voice. You need pretty good radio hearing to hear that voice. There is a voice in there. Okay, great. That's good. Now, maybe we should test tubes next. And then alignment time. Tube test is next. Okay, first tube we'll start with is the 6SA7. This is the mixer tube. Okay, around we go and down. Whoops. There we are. This is a relatively new tube tester for me, but I'm having a good time using it. So, release the buttons. 6SA7, A12678, A12678, and the next row is AC345, AC345. We set this to 35, The test buttons are W and Y. Put that guy in. Put them on. So this tube tester, when you're not actually pushing the test buttons, it's showing you the line voltage reading all the time, which looks okay here. Okay, we'll check for shorts. So we're watching the light here. Does it stay on? It does not stay on, so there are no shorts of significance. In here, W and Y. W and Y. Here we go. So it's a little good. Actually, as I hold it, I think it's steady. It's not. It doesn't look particularly exciting though, does it? Okay, and now we'll test another part of this tube. 128 A56. Okay, give it a moment to warm back up. This comes down to 30, and we're just testing V. Here, let's just go through the shorts, just to be sure. And V. Well, it's on the good side anyway. It's not the strongest tube. Okay, I'm gonna grab the next one here. Let's just move this over here. Did you fall off your chair just now? Now this is not the original kind of tube that came with this radio. This is a kind of like an updated version. This is the metal version, 6B8. I don't remember that being in the tube lineup. 6B8. Let me just peek here very quickly. Yeah, 6B8. So 6B8G is what is normally in here. Let's just check something. So on these metal tubes, usually pin 1 is actually connected to the metal can here. And pin 1 is used then to ground the shield. On this radio, the grounding of the shield was done with these spring-loaded things, another one here. You put the glass tube in, you put the metal sleeve over top, and then these things are grounding it. So there's no need to ground pin 1 in this radio with the glass tube, but with this there is a need. Let's take a look. Pin 1. So pin 1 is would appear to be grounded. Yep, it's grounded. Okay, no problem there. And it's grounded. Looks like original design too. Okay, so we got the right tube and the sockets treated properly. Go. I wonder if it looked like it was factory. So, okay, pop these up, and we got to dial in 6B8. I don't think I've seen too many 6B8 tubes. 6B8. There it is. 6.3. 1, 2, 3. 489, 65 here, WZ for the test. I have to put this on. 6.3, they're all 6.3 tubes. Wait a minute, how can they all be 6.3 tubes? There's a 50L6 and a 35W4. So those two tubes must be series with a resistor, because they're not getting their heater power from transformer. That's kind of interesting. Didn't really think of that until just now. 6B8, 1, 2, 3, 4, 8, 9, 65. Okay, and the shorts. Oh no, it's okay. It's okay. It took a while to charge. The light has to stay on for this to be a real concern. WZ. It's way in the good, 120%. way in the good. Now there's 2 more tests here. And you pop the bottom row and punch in a 5. Dial up to 80. Hit the X button. X is good. Pop the 5, punch a 6, and do the same thing. X. Very good. This tube's in good shape. And of course, it's a replacement tube from the original, so it's bound to be newer. Doesn't mean it's better necessarily, but it's not original. You gotta wonder how many of these tubes might actually be original in here. You gotta wonder that question. Okay, the next thing we're going to do is the rectifier tube. It's a little loose in the socket there. The glass is loose. This is a 6X5. That's an unusual tube, I think. I don't really recall that one either. I don't think I have any of these either. 6X5, that's what it calls for on the schematic. $6X5, here we go. Oh, so this is a 6-volt tube too. So, but the output tube is a 50L6. It's got to have 50 volts on it. I'll have to take a look at the schematic and see how they're doing this. Just to remind myself what I'm doing, 6X5, 6X5, 6X. I'm going to be here. This is the problem with roll charts. 6X5, 6.3, 1, 2, 3, 4. That's it. 1, 2, 3, 4. Of course, rectifier tubes don't use a lot of their pins. 16. And here. And you go. So this has to be working to some degree because the radio works. All these tubes have to be working to some degree. No question about it. The test is W. Short test. So these tubes have usually just a heater, no cathode, and they drive the current right off the heater. Incidentally, from what I've been reading, when you heat up a piece of metal, the electrons are moving all over the place in there, but you could think of it as an out-of-control current. There's a heating effect from it. Well, wait a minute, isn't the heating causing the electrons to move? Or is the electrons moving causing the heating? Which way is it? In any case, in a cathode, you have this heat current flowing, and then you have the current actually flowing off the cathode and moving to the plate. The heat current, if I can call it that, is substantial. Sometimes it's more than the actual tube current. Just the electronic activity in the cathode. And so that has to be taken into account. Of course, the tube designers take all this stuff into account. But I never even imagined it. I never imagined. There's just a internal jumbled up current thing happening. Okay, enough of that. I checked this for shorts, so we're going to push the W button. See, look at it dropping off. That's not a good sign. Oh, it's coming back up. That's really a bad sign. What happened there? It looked like the heater must have disconnected for a moment. I didn't like that. I didn't like what happened there. But it got better. Can't complain too much about that. Now we change the 4 to a 6. 16 still, and we repeat the W test. Same thing. So okay, it's good. I'm not sure what was happening there. Ooh, it got hot. This is a hot tube. Hot. Of course, the tubes that work hard, like this rectifier tube, has a heavy current. You need a hot heater. You need a hot heater to enable the current, if you like. If I can put it that way, it's hot. Like lifting these out by the bulb. squeaky guy. Here he is. That's definitely, it's a, oh, 50L6. Where did I get the idea of 50L6? 6. Okay, so that answers everything. This is also a 6-volt tube. 6K6. Why did I think it was a 50L6? I'm working on too many. You know why? Because I was talking with somebody about their record player. That's why. Pop these out of here. 6K6. 6K6. 6K6, 6.3, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6K6, 50 on the big knob. And you go. Did I say 50L6 again? 6K6. I guess a lot of, this kind of work and other sorts of troubleshooting and repair work, a lot of the time you're trying to work through your wrong notions with other things as you're building up information and knowledge about the thing you're trying to fix. So along the way you get, you're trying to get the puzzle pieces. You don't have them all to start with, but nevertheless you try to make something of them. Your brain's really good at doing that. So you start making up stories as you acquire all the puzzle pieces to the thing you're trying to work on. And stories are wrong at the start. Even though they fit the facts you have in hand, you're completely wrong. You gotta think about that. Think about that. Did I do this? I did this already. And I'm going to do it again because I was talking and lost my train of thought. Uh-oh, kitty at the door. So we're pushing W, one test. Good. My experience with this tester is good so far, and the reputation of this tester is very good. But it's not a full-blown mutual conductance dynamic type tester. It's a souped up emissions tester of some good reputation. So tube's not causing the problem here. So the next thing to try would be to align the radio and see what we get out of that. Great. I think I'm going to end this video here though, and we'll save the alignment for another video. Thanks a lot for watching. Okay, I think I'm set to start the alignment process here. So I've got 455 kilohertz on the signal generator. I got the signal going through a capacitor onto the stator of the antenna part of the tuning capacitor, which is what the instructions suggest. And then I've got my output meter monitoring the speaker, I hope. Okay, so we'll fire up the radio here. Okay, you see the tube's warming up. Volume. Now we might just hear the tone right away from the. We might hear a terrible hum. So the radio should be producing this tone if the IF is that frequency, or I've got the signal generator too low, or something is wrong with my setup. Let's try a few things first. I don't hear anything. Let's give it another shot here. Something's up. Something is up. It's possible this clip I'm using, it's a very difficult spot to get into. Maybe I've accidentally grounded it in there. Let me take a look, see what's going on. Yeah, it doesn't look very good how I have it connected. Let me fix that. Just put this down. Volume down. Don't want to be holding this. Okay. Very difficult to make this connection. I think that's it though. There we go. I had to turn the volume way up. That's strange. Halfway up. And then it seems to come to life. Okay. I'll put her there. Make it so you can see the meter. Now, I'm going to tune the frequency generator. We're going to watch the meter and see if try to figure out what frequency this is really set to. Wow, I don't think I've ever encountered one so far off. Oh my gosh, it's 425. Really? That's unbelievable. Two peaks, one there, bigger one here. Biggest response, 414. Wow! That's just miles out. Miles. Okay, I'll turn this down. That's a long journey to bring something like this back in line. So, you know, I'm feeding the signal in through the whole IF stages, both stages. And when they're close, then that's okay. When they're far out, it might be a bit of a battle bringing these back in. This one has an unusual, this is an unusual arrangement here. So two capacitors up here. So what I'll do is I'll set this in the direction I want to go a little bit. Okay, turn up the radio just a touch. I can still hear it. Wow, you can go quite a ways. It's important you still be able to hear it. And we'll start fiddling around with this. I'm going to use a smaller screwdriver to do it. First, does the metal make any difference here? So watch the meter. Doesn't seem to. Metal screwdriver, okay. Now, is this a locking thing on top here? I think it might be. Come on, go in the slot. There you go. Must be a locking thing. Let's take a little bit of a closer look at that and see what really is going on there. There's some kind of a clip snapped around it. This is an unusual arrangement here. What's the clip for? The metal, bent piece of metal. Then you've got the top thing with the screwdriver. That's typical. And then this lower sleeve. And a lot of dirt. It's not particularly coming clear to me. Well, you know, it's begging to have that clip pulled off. Isn't it? I think it is. Okay. Let me pull it off. See what happens here. I can pull it. Try not to let it fly through the shop. Not much to it. Okay, that clip is out. What happens now? Suddenly the centerpiece can be turned? How would that happen? It's locked in there. What is going on here? Take another close look. Wow, okay, so that clip, whoa, goes way in that piece. So I think all that clip was doing is stopping the this piece from turning. It's just putting pressure on it so it won't wander around. And what's this top piece? It's all threaded too. And then there's a locking piece. Take a wild guess. The locking nut and this outer piece are basically mechanical support for what's inside this can. So it's just kind of bolted it to the top of the can. And this should turn independently. What is going on underneath? Because there should be two adjustments for the two coils. Now this is on, and I'm just winging it with the camera here. This is a little bit scary. Do you see anything that looks like the top of a can? It should be right in here, right underneath that capacitor, I guess, right beside the tube socket. Okay, see if I can figure out how to move this thing. This way. No, this way. So yeah, there is something under there. It's just terrible. This image is terrible. Get a little more light on it here. Hang on. I got to do this differently. I'm doing it the hard way for no good reason. I have all these leads hooked up to the radio, and swinging the radio around is a little bit of a scary deal. Okay, here we go. Here we go. Right in here. That's it. That's it. That is it. Is that really it? There's nothing there. Okay, I'm trying to eyeball it properly. That's definitely it. That's it. There's nothing down here to turn. Huh. So what have they done? Have they figured out this is a way to access both slugs from the top? While I've got it tipped over, let me do the other transformer. Where is it? Where'd it go? Oh, the other transformer's just on the top here. Nothing on the bottom. Nothing on the bottom of either one. Well, I think I've encountered something I just haven't encountered until now. Okay, with all those clip leads attached. I'm not sure what to do about this. Put a stronger screwdriver on it. Don't be so scared. Okay. Where's my... Here it is, right here. Doesn't fit. I doubt this one will fit. So my only real option here is not a hugely big one. Same thing here. Moved a bit there. Oh! Oh no! Oh, I broke the I broke the slot. Well, let's try the other one. See where we can get with the other one. Okay, so we're still running at 436. Is the frequency I'm sending this. And you gotta watch the meter here. Watch the meter. Just adjust this one. Oh, what just happened? Oh, what's happening? What's happening? What happened there? Oh no! I quickly turned the unit off. What was that? Oh my gosh! Okay, so that could be one of these leads popped off. No. Antenna shorted funny. No. Something underneath being pushed up, causing a problem. Let's say I was pushing down on this. Oh my god. This is not really what I wanted. Just when things are getting really good, and so what was it? What was it? What is there down here that's sticking out? Is there anything sticking out? Not really. A little tidbit here. You know what? I still have power coming to this. There, power off. Power off. Push that back a little bit. I don't see that would have caused anything to short or pop. What happened? And do I just turn it back on? That was my head smashing the microphone. Well, the dim bulb lights did I have them on dim bulb? I think I did. The dim bulbs, the lights didn't come on. So whatever's happening is not drawing a huge amount of power. Could be as simple as a tube moving around. Oh boy, okay. There we go. Let's fire it up again. Okay, power's off right now. Now, how am I going to know if it's in a good state or the weird state, or what state was it in? Did it go from the weird state to the good state there? I don't know. Okay, power on, and you should have your eye on the dim bulb. The dim bulbs, there they are. They got a light shining on them, so they're a little hard to make out. Here we go. There we go. We're going. Okay, tube's warming up. Dim bulb showing nothing special. A little more volume. So now that's full volume, but then I was making adjustments, wasn't I? Okay, so situation is as it stands. Huge loss of volume, but it could just be the I don't think it was that low. Oh yeah. Okay, I have no option but just carry on. You know, it could be maybe I shorted the screw head to the can. That can sometimes upset these radios a little bit. You look and see, you can, some of these, you look at the can down here, you can see it's insulated and handled differently from the chassis. Maybe those you gotta be a little more careful with. I'll switch to a stiff non-metallic. I think it would fit in there. Yep. Okay, let's carry on. Okay, that's as high as we're going to get on that. It's really low. Other screw. Wow. Oh, I just did it again. What the heck is that? So the volume control is very weak down low. Oh, it's come back. Listen. Down. It was there. And then it turned up, it goes down. And then there's a... I think the volume control is breaking. Kind of weird that I would be pushing up here and have it snap like that. Lots of weirdness here. Let's keep going. Okay, so we're tuned up on this transformer to, please, I'm blowing my ears off. 436. So we gotta take it up to 455 now. Just barely hear it. Other guy. What, did you see it jump there? Is there something going on with this? I don't know. Oh! Sound of a gun. What was that? Something going wrong here. Is it the tube? You know, the tube's in a socket. That's why I'm suspicious of the tube here. No, it can't be the tube. Is it this tube? These are the ones I'm kind of flexing a bit. I can't imagine. Is it this thing? So there's a short developing right in the capacitor that I'm turning. I think that might be the yes answer. Oh, heavens! Oh! Turn it off and on, and the crazy sound went away. Cold solder joint is what this is kind of suggesting to me. Underneath. Gonna kill the power, because if I'm gonna lift this up and move it around and it's gonna do funny things, I'm gonna jump and throw it away. Should I remove the equipment? Let's tip it on its side and try to keep the equipment connected. Okay, buddy. It's probably something I did that didn't take quite right. Yes, sir. Okay, so I thought this alignment thing would just take a few minutes, but apparently it's going to take a lot longer. How long have I been going? Another 20 minutes. Okay, can we do it in 10 minutes? Can we find out what is going on here in less than 10 minutes? Let me get the plastic pointer. Okay, we're flipping it back on. She's on. We'll just go through all my capacitors I put in. And, oh yeah, so the problem is in. it's right under the can here. Nothing seemed very sensitive there. Shows you how important the wiring is in these radios. I put in a bit of a low voltage capacitor right here. I wonder if that was a mistake. So we're going to measure the voltage on the capacitor. $115 volts. It's rated at 160. That's not going to be the problem. Now I also put it was a 160 here. Frankly, I think a brand new 160 capacitor, you can probably put 300 volts on it and really not be concerned at all. That's this guy here. Volts. Well, it sure is singing. That's tuning. That's a little odd. I wouldn't think tuning would have an effect when you're doing the IF stuff. Something's happening here. Volume control, eh? So when I'm working the volume control, funny things happen. That's really weird. It's not even a really sudden thing. Strange behavior of the volume control. I turn it down, it gets a little louder, and then at some point it just really goes wild. And then there's that weird clicking. What is that clicking sound? It sounds like a relay snapping. Oh, you've really boobed it up this time, Jim. Now would be a good time to stop and call it a day at this point, for sure. Tomorrow, it's troubleshooting on this problem, and good luck. Son of a gun. Well, I hope you're enjoying this. I thought I'd get them all done today, but I'm not gonna, and it's gonna take another day. See ya.